Okay, guys, 2.7 continued. Next set of transformations are reflections across an axis. Okay. So the graph of y equals negative f of x is the same as y equals f of x reflected across the x-axis. Okay. So the way to think about this is this. The x's don't change. Okay. So if I have some graph that goes like this, and this is x comma f of x, right? Then if it's reflected across the x-axis, so essentially what we're doing is we're taking all the y's and we're just multiplying them by a -1 out front, we're going to get something kind of like this. So this would be x comma negative f of x. Okay, that's the visual of kind of what's going on. So right here it just says if xy lies on y equals f of x, then x negative y, essentially what I put right here, lies on y equals negative f of x. Now, if the negative is appearing and it's affecting the x, so here it's like we're making the y's negative, here it's like we're making the x's negative in the function. It's the same as y equals f of x, except for it's reflected across the y-axis. So if xy lies on y equals f of x, the negative xy lies on y equals f of negative x. So for example, in this case, if I have the points x comma f of x, remember f of x is the same as just saying y. So you can put a y here if you'd rather. Okay, then that means if it's f of negative x that we have this. So these are the same y values. This is just negative x f of x, or negative x comma y. Okay, so you can see reflected over the x, reflected over the y. So for example, let b of x equal the square root of x, so that's our base function, and graph the following. So I've graphed out the base function. Okay, so b of x equals square root x. And now I'm going to see, okay, well, I need negative b of x to be negative square root of x. And according to what I have up here, if I'm familiar with my transformations, I've changed the whole y value. So I know that this is a reflect over x-axis. Okay, so I'm expecting this to flip down here. Let's see if that is, in fact, the case. So I have x and I have f of x. Let's try 0, because that's one of the points I am tracking. Remember, I'm tracking the points. Well, then that's negative square root 0, which is 0, right? So 0, 0, nothing new there. What if I try x equal to 1? That's negative square root of 1 is negative 1. So I'm right here, 1, negative 1. Look at what happened. The y switched signs, just like what I had going on up here. So this is doing what we expect it to do. Let's see about 4. If x is 4, I have negative root 4 is negative 2. So I have 4, negative 2. It looks like exactly what we thought would happen is happening. Okay, so here's f of x. So it reflected over the x-axis just as expected. Compare that to this next one. G of x equals the square root of negative x. Now the negative is inside with the x. So essentially it's like we're taking all the x's and we're making them negative. That's what's making me think we're going to go this way. So our base function here, once again, is the square root of x. And to get to this, I need b of negative x, right? Because this tells me, oh, go back to your base function and replace the x with a negative x. That gets me here. Okay, so that's exactly what I want. And what does that do when the negative affects just the x inside of the function? Well, that's a reflect over y-axis, right? Because it switches all the x values from positive to negative. So actually, it looks like it's changing the domain of this whole thing. In fact, we're going to get the opposite domain, right? The domain here is 0 to infinity. I think we're going to get negative infinity to 0. Let's see if that does, in fact, happen. X and f of x. Okay, so once again, if x is 0, we can do that. Square root of negative 0 is 0. That's fine. Now, if I notice if I put in a positive value, I'll get a negative under the square root. We can't do that. So I need a negative x value to get a double negative. So I'll use negative 1. The square root of negative 1 is the square root of 1, which is 1. So notice I have this point here, negative 1, 1. And finally, let's do likewise for negative 4. The square root of negative 4 is the square root of 4, which is 2. So I'm right here, negative 4, comma 2. We can see, oh yeah, reflect over the y-axis, exactly what we were talking about up here. So that's when we just change all the x's to negatives. Now, I need to go off on a tangent for about a video and a half here and talk about symmetry in general, okay, because this will be very important. So I'm going to take a break. I'm going to show you one more transformation in the next video and a half or so, but I want to talk about symmetry in general. So if I have something like y equals x squared, notice that that has xy and negative xy. Notice that that is y-axis symmetry, right? We just kind of talked about that. That's like when you replace an x with the negative x, okay? So that's like saying negative xy and xy are on the graph. That's the same thing we're talking about. I'm just pointing out one of these that is symmetric about the y-axis, okay? Not in the context of transformations right now. Now over here, generally, we're not going to ever have this as a function, still a relation, but this is the graph of y equals plus or minus root x, which is not a function, or x equal to y squared. We've sort of seen this before. Notice they have the same x's, but different y's, just like we did in that first transformation before when we got the new one. This is x-axis symmetry. It's a mirror image across the x-axis. If xy, in this case, xy and x negative y are on the graph. So in general, how do you test for symmetry? Why do we test for symmetry? Well, if we know one side, then we know the other, so it helps us graph. You can look at the graphs, but how do we check it algebraically? I'm going to show you. Test for symmetry. Okay? So if we look at this one, A, y equals 2x to the fourth minus 3. If I want to check the y-axis, right, we know in the y-axis that we switch the x's and we get the same y. So I'm going to take x's and I'm going to change them to negative x's and see if I end up with the same thing. Okay, so let's see what happens with that. So for the y-axis symmetry, I have y equals 2 times negative x to the fourth. That whole negative x has to go in parentheses, raised to the fourth, minus 3. And I know that this means y equals 2. A negative number to the fourth is the same as the same number to the fourth. Okay, and looking at that, I can tell that this is the same thing. So I have y-axis symmetry. Okay, this is the safest way to check. If you just look at a graph, it may look symmetric, but it may not be. But since you do have a graphing calculator, why not check this and kind of see, oh yeah, if you can see, oh yeah, it does have y-axis symmetry. The next thing I want to check for is x-axis symmetry. So for x-axis symmetry, I have to replace y with negative y, right? That's what we talked about up here, okay, for x-axis symmetry. So this tells me that negative y equals 2x to the fourth minus 3. What I'm going to do is I'm going to resolve this for y. Multiply both sides by negative 1 to get this. Y equals negative 2x to the fourth plus 3. Notice that that is not the same. If it's not the same, it has no symmetry, so no x-axis symmetry. That's how we check these. Okay. If I look at this one, I'll do the same thing. First, I'll check for y-axis symmetry by replacing x's with negative x's. Okay. That means y squared minus negative x squared equals negative 6. Well, a negative number squared is the same as that the positive version of that squared. So y squared minus x squared equals negative 6. It's the same, so I have y-axis symmetry. That's good. How about for x-axis? Replace y with negative y. So you want to know what to replace. And it's a similar story here, right? negative y squared minus x squared, okay, that is going to be equal to negative 6. We know any number that's negative and then squared is the same as the original number squared. So it looks like this also has x-axis symmetry. Okay, cool.